Good morning, everybody. Welcome to our webinar, Streamline the Migration Management of your Microsoft apps on AWS. My name is Latson. I'm a Senior Partner Solutions Architect for Amazon Web Services. And with me, I have Paul and Michael, Paul from Rackspace, Michael from PowerChord. And we're going to be talking to you about migrating and managing your Microsoft apps on AWS. A couple of housekeeping points is we're going to be recording this webinar, and we are going to be sending out emails with the link to the recording of this webinar. So if you feel like you need to come back to any of this, or you want to review it again or send it to any of your colleagues and friends, you will have this link and you will have this webinar. So let's proceed with the webinar. Let's just make sure this thing works. Here we are. So I'm going to start off with Windows on Amazon EC2, and after we are finished with the presentations, we're going to have a live Q&A, which I will be moderating. So let's jump straight in. What is our solution at AWS? Well, we want to make sure that we retire technical debt, that we accelerate your digital transformation, not just for your companies, but for your customers too. And we are obsessed about lowering the cost. I think more than 50 times or 60 times have we lowered the cost since we started with AWS. And what else do we offer from AWS besides all the many services that you may be familiar with? Is that our commitment to making Windows and Microsoft workloads first-class citizens on AWS. We started off by being the first cloud service to actually have Microsoft workloads, and we have added many services and features, as well as AMIs and options for you to run Microsoft workloads on AWS. Everything from enterprise workloads to .NET to developer tools and everything else that comes with it. So what are the benefits of running? Why you should be considering running Microsoft workloads on AWS? Well, it's one, and first and foremost, is accelerate innovation, reduce cost, become more agile, as a company and as an organization, and make your customers more agile, and improve uptime and performance for all of your workloads dramatically, might I ask, and tap into extensive AWS partner network in the partner team, which I'm proudly proud of. So what are our technology challenges? Well, today, organizations and customers want to focus on delivering customer value instead of just time-consuming hardware maintenance. Nobody really wants to, invest copious amounts of energy, money, time, into hardware and maintaining that hardware and all that, and then having to be limited by the hardware that you have, not being able to innovate, not being able to quickly deploy things, not being able to, go outside of the constraints of both your hardware and licensing that might be keeping you down. So you want to also have access to broad and deep set of cloud services, different types of services, different types of platforms that are already pre-created that you can take advantage of today, that will accelerate both your digital transformation as well as your deployment and availability scenarios, tenfold, maybe even more. So those are very exciting scenarios, and you want to provision these resources on demand. You want to reduce completely lengthy procurement and deployment cycles. Every time when you have some idea or project that you want to deploy, or something that you would like to try, you don't have to go through these copious processes and beggings and expensive cycles to actually get this up and running, not knowing whether it's going to be successful or not, and how much of a risk and upfront cost that's going to be to you, right? And all the complexities around integrating these new technologies. You wanna really have simplified way of integrating and using all these different services and technologies on AWS side together with your Microsoft workloads, together with your Microsoft resources. You want to be able to decouple those monolithic applications. You want to be able to upgrade and get up to speed with the latest and greatest of the architectural concepts, within your organization, with little to no cost in some cases, even, when you venture to do that. So how do you reduce cost? Well, you only pay for what you need. It's literally, it's like a utility company type model, right? When I switch on the light comes on, I pay for the electricity for that light. When I switch it off, the light is off, I'm not paying for it anymore. Same goes for here. All of your capital expenditure, everything, all of your massive investments into this increasingly expensive hardware that you have to spend for many years. A lot of it, kind of not even being used properly, or not having, the right teams not even having sometimes access to it, or being able to innovate. You want to switch all of this CapEx into OpEx, into operating expenditure, right? Becomes a lot more cost effective, a lot more easier to manage, and so on. And you want to bring your existing Microsoft software licenses. You don't have to trade any aspect of having to go over to AWS or any other cloud platform, and specifically AWS, because you can bring your licenses. You can bring, thanks to license mobility, thanks to your EAs and all that, you are able to reuse and bring your own license options. You are able to reuse your current Microsoft licenses. You can continue to derive value from your existing investments by actually having a hybrid architecture. And a lot of our customers, obviously everybody starts off with a hybrid architecture of some sort, whether it's a part of the actual migration to go all in to AWS, or whether it's maintaining the hybrid architecture between your current colo data center, or multiple data centers, or multiple points around the world within AWS. And continue deriving, that value of the investment, whether it's from partner or from your own, data center and your own colos. And you can, by using and taking advantage of things like EC2 reserved instances, you can save up to 70% off of the on-demand price, which means basically committing to use instances that you will be using for a year. And that way having even more drastic price drop and cost saving for you and your organization. And you can just simply allow people to allocate whatever hardware needs they need to have. There's no expensive procurement processes. There's no refresh costs. There's nothing to worry about. All of this is being taken care of by AWS. What about agility? Well, I talked about the reducing lengthy procurement development cycles. Now you're able to innovate. You're able to get any of your ideas out there, test them out, get them up and running, see if they work or not. And what does that do? That creates disruption within the market, and all that allows you to disrupt. I mean, I've read so many articles, so many independent ways, that through automation and agility, and how that actually gives you a quick way of providing and provisioning all of the resources that you need in no time, testing those concepts out. That allows you to have, not only that it allows you to have disruption, but it comes out to like even 440 times faster than most other organizations that do not automate, that do not take advantage of DevOps and many agility options that cloud platform like AWS has got to offer. So we're talking about not just the CDCI options for your .NET workloads or any other development workloads, but also deploying microservices, infrastructure as a code. So having the entire life cycle of updating and maintaining configuration management of your entire infrastructure, logging and monitoring, having platform as a service, we call serverless architectures that you can take full advantage of and create massive, fully available, highly scalable systems in a fraction of a time that you used to, without having to worry of any aspect of infrastructure behind it. and of course version control of all of these aspects. So any of these, right? Whether we're dealing with containers, serverless, whether we're dealing with normal kind of virtual instance implementations, and improving uptime and performance. So when it comes to AWS, and this is something that has been very unique, especially when it comes to availability concept. What concept of availability zones is with AWS? Well, availability zones within one geo region, they're basically clusters of data centers that are on a different fault plane, flood plane, geographically displaced. So these are clusters. So this is not, a fault tolerance within the same rack or within the same data center or anything like that. These are different separate clusters of data centers, and having just a normal deployment of any of the Microsoft enterprise workloads, any of the Dynamics or SharePoints or .NET applications, Exchange or anything like that, in a normal kind of redundant fashion between two availability zones, that really counts as a full-blown disaster recovery that very few companies in the world were able to afford, up until this point, up until AWS and what we have to offer. So this is a tremendous value, where just normal deployments become fully available, highly available rather, DR type scenarios without having to have a DR scenario, in fact. And you can leverage variety of EC2 instance types. So you can make sure that your workloads that are, let's say, more transaction optimized or more batch optimized are using the optimized hardware behind it to run in the cheapest, most effective, and most efficient way possible. And we have ways of deploying that on, taking advantage even on clusters such as, ECS, Elastic Container Service or EKS or something, and having ability to create affinity towards different sets, of instances or where you want to be running, and in that way optimize your microservices, as well as any of the normal traditional implementations of both your applications and your .NET development and everything that comes with it. So and you can immediately respond to changing resource requirements using AWS auto scaling and elastic load balancing. These are massive industry standard services that a lot of our main customers are using to scale to any of the demand or any of the millions of users that may be accessing their resources or anything like that. So Windows workloads can take advantage of all these industry strength services that we have available. And talked about already the availability zones. And you can tap into the extensive AWS partner network. You can engage with tens and thousands of AWS partner network consulting partners, as well as ISVs, technology partners, and that offer many of the solutions. My team works directly with them. You can develop a Windows migration strategy by leveraging partners and that hold specific Microsoft workload competencies. So this is something we actually qualify partners based on their competencies with specific Microsoft workloads, and specifically with Microsoft workloads in mind. You can leverage the software your organization is already familiar with, or you can try out new technologies and use our ISVs and solutions that ISVs offer through AWS Marketplace. And on licensing, you have license included basically with on Marketplace or through AWS Management Console. So you have Windows Server licensing as well as SQL that you can actually directly rent from us. They are included in your AWS bill and the whole thing. So that means that you don't have to buy additional licenses on your TrueUps or anything like that in order to innovate, in order to test, in order to develop, and all that. You can just use it. You can switch off when you don't use it anymore, and keep it at that, actually bringing you immense cost effective and a cost saving value here. Or you can bring your own licensing. You can bring it, like I said earlier, through license mobility, or you can use EC2 dedicated hosts, for specific licensing scenarios. You can extend the license investment to the cloud and pay only for those AWS services you consume. On a bring your own license side of things, you are responsible for that license compliance at that thing. And of course, we are here to help and assist you. My team is, our partners are, and so on. And with that, I'd like to hand over to Paul and Michael afterwards. Thank you so much. I will be answering your questions and look forward to the Q&A part.
All right, great, thank you. Appreciate that, Zlatan. Hello, everybody. This is Paul Gore. I'm a solutions architect with Rackspace, and today we have with us Michael Van Diest, who's Director of Engineering at PowerChord. And we're going to go over a scenario, the migration that PowerChord went through. Rackspace helped them move from a legacy environment, dedicated server environment, into AWS, and we're going to cover that today. So PowerChord, let's cover the company first. So PowerChord is a digital platform. They have a digital platform that helps manufacturers grow online engagement and in-store sales through their dealer networks. They have industry expertise coupled with advanced technology, which provides easy-to-use, scalable tools that help their customers compete against large online retailers. So think in terms of local web storefronts that provide a more personalized experience for their customers in different regions. So they operate in 28 countries. They service over 10,000 local sites worldwide and are headquartered in St. Petersburg, Florida. So what brought PowerChord to Rackspace and AWS? Well, they had a legacy architecture that had been working for them for some time, but given that it was in dedicated environment, it didn't afford the opportunities that a modern cloud architecture would have. So for example, they were using Microsoft IIS web servers, which with session state stored locally. They were doing load balancing via IIS application request routing hosts. They had a custom content delivery network for image resizing. And finally, they were using Microsoft SQL Server with DTC for transaction sharing. So what did that result in? Well, a number of different problems that we are going to cover here quickly, and then we'll get into how we solve those. So the first thing that comes up is single points of failure. One host acting as a load balancer, and failure means that none of the hosts supported by that load balancer are accessible by the public. So what you end up having to do is send someone out, right? In PowerChord's case, they used a third party. So you raise a ticket, you get a resource out to repair the issue, hopefully quickly. But then you get to the next phase of where resources are involved. You say you want to scale. Well, what that means is you have to send, again, someone on site to add a host, resulting in a delay in that scalability. Additionally, other things are really too time consuming in that model. So things like backups, and in PowerChord's case, specifically, they had a complex routing rules, server level routing rules that needed to be managed by an individual. All of this combines to result in really inconsistent reliability, performance, and efficiency. So what did they need? PowerChord needed cloud technology and a managed service provider. So most of you are probably familiar with the quote from Werner Vogels, the CTO of Amazon. He says that he likes to say everything fails all the time. Well, there's a quote from him on his blog. I think it's called All Things Distributed, and he goes into a little bit more detail, and I think it was interesting. He says failures are a given, and everything will eventually fail over time. So since it's a given whether you're using high quality hardware or the lowest cost components, you're still going to have failure. And I think that was interesting because it kind of points out that you can't just throw money at the problem and a legacy architecture to resolve it. You have to re-architect it. And so PowerChord wisely gauged that their customer experiences could be improved by moving away from a monolithic application architecture and that had limited ability to scale. And so they knew they needed cloud technology that would allow them to have application scalability, managed infrastructure, and database services, more consistent performance, a resilient architecture, and an improved security posture. From their MSP, they wanted to have someone with a deep knowledge of databases, specifically Microsoft SQL Server. They wanted a provider with extensive AWS experience that holds industry credibility and that would also work with them as a partner. So why AWS? Well, Zlatan covered a lot of that already, but specifically for PowerChord, they wanted to make use of RDS, Elastic Load Balancing, Amazon Elasticache for Redis, AWS Directory Service for Microsoft Active Directory, and AWS WAF, which is the Web Application Firewall. Each of these was used for PowerChord's architecture, but this is not an exhaustive list, obviously. And then Zlatan covered the other major benefit with AWS, which is that global reach. That in PowerChord being a global company, this was important for them. So Rackspace, they selected as their audited AWS managed service provider for a number of reasons. We have a history of managing production environments for thousands of companies worldwide. We provide proven tooling and expertise to guide you and PowerChord in migrating the applications to AWS. And then expertise in application and database management move PowerChord beyond just a migration and allow them to take full advantage of the flexibility and resilience of the cloud. So what was that process? What did it look like? Well, we worked together with our customers, and so in this case, we worked with PowerChord. We like to kind of organize things into this a framework. We have 6 stages to that framework. They are plan, analyze, design, migrate, manage, and optimize. And plan, it's kind of obvious, but you might cover things like overall strategy, financial decisions, maybe a roadmap that governs what you want to see, 3 months, 9 months, 1 year down the road. Analyze, you find the issues in the existing architecture, find places for improvement. Maybe you also define your security requirements. In the design phase, we're gonna set up greenfield applications. We'll go over the basic architecture, potential automation, and maybe even run a POC, a proof of concept. Then we get to migrate, where obviously you're doing actual data migration. Before that, you're doing test plans, you're getting approval from both sides. And then manage. This is where Rackspace is really known in the industry. We provide fanatical support at this stage where we're actively monitoring your environments, we're helping you troubleshoot issues, and we're helping you maintain that security. And then finally, optimize. This is where you've got your application deployed, you're migrated, and now you're looking to improve it. You're looking to modernize it, perhaps. Maybe you weren't able to take full advantage of all of the managed services you wanted to, so you could get migrated into AWS, but you want to get there. And so we provide architectural guidance, potentially things like cost optimization, and finding efficiency, right sizing for instances and things like that. So what did the PowerChord migration sequence look like? Well, we really kind of summarize it into four steps. This is an oversimplification, but it really kind of helps you understand the overall what's happening. So first, we start with a landing zone. And a landing zone, as AWS describes, really as a baseline environment that encompasses account strategy, network design, foundational security, and then you can incorporate things like identity and directory services. So at this stage, you might be, we might work with you to identify how do we want to set up the account structure and map that to VPCs. Do we want to have a VPC per account, or do you want to have an account and with all of your VPCs? You might do that to segregate access from, say, you want to limit developers to one development VPC. We can help you identify that account structure, and we did that with PowerChord in this case. The step 2 would be to migrate the database tier. For PowerChord, that was an MS SQL Server running on dedicated instances, dedicated hardware. So we were able to deploy RDS for SQL Server for them. In their case, we're able to do a backup and restore for migration, but there are a number of different ways that you can get your data into RDS, and those listed here: import, export, SQL log shipping, hybrid architecture, and of course, AWS database migration service. Step 3 really gets into the other tiers that you might have. So in PowerChord's case, that was their web tier. So, you know, there's a couple of ways you can handle moving instances, Windows instances. You could do a manual migration, which is where you build new servers and then migrate the applications and data. You could also do tool-based migration, which is block level. So think, you know, exporting a VM and importing it. Generally, we recommend setting up a new Windows host and migrating data. That seems to reduce problems when we follow that methodology. So at this stage, you do extensive testing, and you ensure that you maintain that rollback capability. And finally, step 4, the actual cutover, the fun stuff. So in PowerChord's case, able to do a DNS redirect of the CNAME redirect to the new load balancer. What this does is allow you to maintain your legacy environment. You can switch back if you need to. Okay, so now we've kind of covered what did that what did that migration process look like. When complete, what was PowerChord now working with? What was that post-migration architecture? What we wanted to do really was break that architecture up into the tiers and then address them individually so that we could, because they each kind of speak to a different aspect of that moving from a monolithic application to a decoupled architecture. And so in this case, we start with load balancing and scaling. So the interesting thing that becomes enabled when you move into AWS with EC2 is auto scaling. And combined with the application load balancer, you see some pretty major benefits. So you'll notice the green arrows here on this diagram. The application load balancer is able to monitor the health of the instances in this auto scaling group. It can do that, and then when it detects an issue, it can remove instances that have failed, for example, failed a health check, and then replace them, and all automatically. Another major advantage is the ability to balance across availability zones. So what this means is that instances, newly launched instances, will be sent into another availability zone to keep that even, so that in the event of a failure, you're still working with the proper amount of EC2 instances. And then dynamic scaling. This is really an interesting aspect of a post-migration architecture, because it allows you to set a demand curve for your applications and follow it. So you no longer need to manually provision. You can have policies set up that will automatically expand your capabilities or shrink them based on needs. So you could do a scaling policy based on CPU utilization. My EC2 instances Windows hosts are running at 95% utilization. I want to, add instances at this point. You could do minimum and maximum instances. So you could say, we know we at a minimum, no matter what our lowest load is, we want to have 3 instances running at all time, but we want to cap that as well. We don't want to have a runaway process that scales up to thousands of instances. We're going to cap it at 20 instances on the Mac side. And then you could also do something like go by request count per host. There's a number of options there. So the next thing we wanted to cover was the caching architecture. So previously, Powercord had been doing a number of different things that really could have, that moving to AWS allowed them to offload. So output caching was one of those things. They were doing ASP.NET output caching. They were able to move that into Amazon Elasticache for Redis. And what that allowed them to do is reuse pre-processed copies of pages rather than going back through the web host, the application for each request. And then additionally, we're able to store session state in Elasticache as opposed to keeping that on the instance as well. And what that does is improves performance, obviously, across the board, because Elasticache is going to perform faster than those same functions would on instance. It's a very fast in-memory data store. It's sub-millisecond latency. So that allows things like internet scale applications and a more personal application experience, since you're able to cache session information with Elasticache. And then the third tier on this post-migration architecture for Powercord was the RDS for Microsoft SQL Server tier. And this is a really interesting one as well. It was a major benefit win for Powercord because it allowed for to simplify their deployments. Because RDS is managed, it supplies there's a number of things that come from that. So monitoring metrics are automated. You can keep track of what's happening with the instances easily through CloudWatch. You get automatic software patching, and Amazon AWS managing the operating system and things like that really takes that load off. So I know that Michael has talked consistently about how cycles were freed up for their DBAs, and that allowed Powercord to focus on the application itself, which is really important. So additionally here, you get predictable storage performance. You can do provisioned IOPS if you want. And then a highlight here is availability and reliability. So you no longer are dependent on one host in an environment, and then keeping that one host up and running. With RDS, you can do multi-AZ deployments that let you automatically provision a primary database and one availability zone, and then maintain a synchronous standby in a different availability zone. And in the event of a planned maintenance or an unplanned disruption, RDS automatically fails over to that secondary, that standby MS SQL RDS host. So that allows your database operations to resume quickly without manual intervention. And here's a look at a simplified architecture. There's a number of things we didn't that are in play that we didn't include here on this diagram for ease of reading. But you'll notice the S3 icon. There was extensive use of S3 for Powercord here, and most people know it as an object store. You can keep static content there for your web applications. Backups are there, stored there as well as CloudFormation templates. And Michael was going to speak a little bit about how important that this S3. What are some other ways that it really improved their posture by using S3?
Cool. Thanks, Paul. Good morning, everybody. Yeah, so in terms of the S3 implementation, when we worked with Rackspace solution architects to, figure out how we were going to do all this, offset all these loads, one of the tasks that we needed to do, one of the things we needed to do is to figure out what to do with FTP. It's a legacy application, so we have plans to do FTP uploads of, synchronizing product catalogs and organizational information. And so when we went to go through the process with Rackspace, during the planning process, it hadn't occurred to us what to do with FTP, because we were just so used to having it, but there actually is no FTP service in Amazon. You can obviously, spin up a server and run an FTP server, but we didn't want to do that. We didn't want to, running a FTP infrastructure is not something we want to get into. So Rackspace helped, make that recommendation that, well, one, there's an option to use something like I mentioned, like a cloud barrier or something running on a server backed by S3. But what we ended up doing was reaching out to our clients, informing them, that FTP is a somewhat antiquated architecture or a system, and we don't want to use it anymore, and cleared with them that they could shift to doing direct S3 access with us. So that helped a great deal. And so what we also did was take our EC2 instances with our IIS servers that need to use a shared file system, because that was another problem we had, was how to share the file system between an autoscale group. And so what we came up with was, internally in our own code, we had an interface that kind of abstracted the iFile system. And what we did was backed that with S3. So to our application, we wrote some very simple code to let .NET still think like it's talking to a file system natively, but what it's really doing is talking to S3. So that allowed us to totally eliminate volume dependency for the shared assets between the EC2s, which makes scaling a lot easier. And like I said, also allowed us to get rid of that FTP infrastructure.
Right, and the other thing with S3 that you get to is it's just a very reliable source for storing data, so you no longer have to really worry about whether that critical data is available. More than likely it is when it's sitting in S3.
Right.
Another aspect that we had talked about, Michael, I know you wanted to cover, was the move to infrastructure as code via CloudFormation, and how this whole architecture was really made possible through that. Did you want to speak to that a little bit?
Sure. Again, going through the setup with Rackspace as well, and I think on our plan with Rackspace, we chose the Aviator level, which gave us a little bit extra level of support as well in defining how we get all this spun up. So we understood CloudFormation. We're certainly not experts in it. Had barely knew it as just a cursory knowledge of the capability of it, but not how to do it. So what Rackspace did as a partner was helped us, identify that architecture we had to create, actually write the CloudFormation templates for us to, one, get the VPC set up. Like you said, Paul, that landing zone stuff was all, we didn't have to do any of that. That was all created for us. And then looking at each tier of our architecture and doing CloudFormation for that, as well as getting into bootstrapping our machines through our deployment process and also getting all that automated. So you can imagine as we auto scale, I think one of the bigger challenges we had too was how do we, when you auto scale, how do you get your code out there to the new instances? Right. And so we use a Octopus deploy to push, historically, to push code out to our servers. So what we needed here was, well, when a scaling event happens, we need that server to actually go grab the latest code before it becomes healthy. So the Rackspace solution architect did the majority of that work for us, because working with multiple clients, you guys had come across Octopus deploy before. So again, we didn't have to learn how to do that. We didn't have to learn how to do CloudFormation. And now we have, via those CloudFormation templates and stacks, we have a way to spin up this infrastructure at will, scale it, change a parameter to, potentially reprovision whole segments of the system where, something that would have taken us days before literally takes minutes now. So not having to get across that sort of learning curve for CloudFormation. It's not extremely hard to do, but we have more important things to do than DevOps. We're in the business of providing value for our customers, not in maintaining infrastructure. But obviously it's our responsibility to keep the infrastructure as fast and as scalable as possible, but we don't have to be thinking about it at all times. So CloudFormation and Rackspace helping with that was a huge win for us.
Great. Yeah, thanks, Michael. So I mentioned when I showed this slide initially that this was a simplification. We actually ended up utilizing a number of other services as well, and we bumped this forward. So wanted to go over some of those. So the first was managed Microsoft Active Directory through AWS Directory Service. RDS requires this. It can be set up with a trust existing domain in your an existing domain in your own infrastructure, but it really is part of that landing zone. We work with you to get that defined ahead of time. We talked about S3. A big one for PowerChord was AWS Certificate Manager. I know, Michael, at one point you had talked about how important the ACM was, that integration with the ALB. Did you want to speak to that a little bit?
Sure. Yeah. So when ACM came out, I think somewhat recently, we had been using AWS in a non-production manner for running our dev environments for some time on our own without Rackspace's help. But when we switched over, we had been using ACM there for cert generation, which gives you as long as you got domain ownership, you get those free certs, you get the auto renewal. So not only is there a massive, basically a whole cost elimination of certs happening there, but also the management of certs, renewals, having someone go generate CSRs and dumping them onto the machines. So once you have ALB and ACM hooked together, you don't have to do any of that stuff anymore. And for us, that's a huge task because we have numerous clients that as Paul mentioned as well, that running up to 10,000 different subdomains, and some of those a lot of different hosts within that, or Apex domains within those hosts as well. So cert management and cost was a big deal for us, and so now it's just a no-brainer. We don't even have to deal with it. We just add a couple DNS records either into Route 53 or in some cases some external DNS providers. Amazon ACM, does the verification, and boom, you got your certs totally free, totally managed. And in the case of us using the DNS automation with it as well, so we get complete hands-free auto renewal of all the certs too. So another huge time and cost savings there.
Right. Yeah. Another example of where a managed service can make a big difference in your architecture. We covered CloudFormation. We've talked about that. Infrastructure as code. Interesting one here, AWS WAF, Web Application Firewall. That helps protect your web applications from common web exploits, say, such as SQL injection or cross-site scripting. There are, in the marketplace, there are predefined rules you can consume from various vendors as well. Amazon Route 53, Michael just mentioned that. That is a highly available and scalable cloud DNS web service. And then AWS Key Management Service, KMS, managed service that makes it easy for you to control the encryption keys used to encrypt your data in this architecture. It also has deep AWS service integration. And then finally, AWS Shield, that is managed DDoS protection. So what's the takeaway here? Well, what PowerChord gained by working with Rackspace as an MSP in their migration, moving their this Windows application into AWS, they along each step we worked as a partner with PowerChord. They were able to leverage our deep expertise, and then we also provided that 24/7 presence. So Rackspace is global in support, so any global companies will really appreciate having access to that. I think that covers it, unless I accidentally skipped. I did. It moved a little fast on me there. So what are some specific wins that PowerChord had with Rackspace and AWS? So number one, we've covered it. They were able to offload infrastructure management so that they could focus on their core product. Michael talked about how important that was for them. They had cost reduction by matching provisioned resources to actual utilization. Increased uptime by making use of auto scaling in multi-AZ design. Application performance improvements by decoupling functions. Remember, we moved output caching and session state into Elasticache, so that automatically, that will result in performance improvement right there. Increased agility by enabling a DevOps process through infrastructure as code with CloudFormation. And then finally, improved capability by leveraging Rackspace's deep expertise and support for Windows on AWS. And that covers it. So thank you very much, Michael, for helping me out and speaking to your specific issues in the resolution. I appreciate that. And
thank you for having me.
Yep. And now it looks like we do have some time for questions.
Yes, hi. Yes, we came to our questions and answers section. So we do have several questions here. I'm going to read them out. In the diagram, there was a VPC endpoint connected to S3. What does that provide? So we have, several, two different types of VPC endpoints. There's gateway endpoints, which is basically a gateway that targets specific route in your route table. It allows, and that's for Amazon S3 and DynamoDB. It basically provides private IPs to have direct access to these services without having to go outside or without being exposed in any other way. So it provides specific access to the network, and those are gateway endpoints, and that's just that's with specified routing to the service. But we also have interface endpoints like which is basically an elastic network interface with private IP address that serves as an entry point to the traffic destined as a supported service. And that works with API gateway, CloudWatch logs, code build, EC2 API, elastic load balancing, Kinesis data streams, KMS, a key management service, SNS, AWS service catalog, as well as you can have endpoint services that are hosted within other AWS accounts provided by our partners, and that's powered by AWS Private Link. So I really implore you to check that out. There's another question here: can AWS directory service be set up to trust a company existing Active Directory domain? Yes, absolutely it can. You can establish a one-way or two-way trust, and there are significant benefits also to, besides the one-way, obviously, there are significant benefits as well to establishing a two-way trust, where you can actually take advantage of a single sign-on to both, CLI, command line interface, for your, ops and developer teams, as well as on the other hand, a single sign-on to the AWS console that is included with that. Important to note that you have an OU that is all yours, that you just administer and stuff. We don't have access to that. I know there's a lot of questions that come with that. It is one of our most popular now emerging services that is being used. Once again, another thing I implore you to check out in more detail. And the last but not least is the AWS, at least for me, and then I have a few questions here for Paul and for Michael. AWS Web Application Firewall looks interesting. Are there any guides or examples to help us get started? Absolutely. So we have actually, I'm going to include this link that was provided. I think. Thank you, Paul and Michael. You guys know this very well. Let me just send it to all. So they not only do we have extensive documentation for web application firewall, but as Michael talked about it, I think explained it in more detail early on. But we also have a solution which I just shared with you that includes very comprehensive cloud formations that deploy entire infrastructure with pre-configured web application firewall that is very extensive, and you can actually use and apply it, change it and learn from it, and or use it within your environment. as it is. It's the link also, not only does it have the link to the actual CloudFormations and allow you to directly deploy it into your account, but it also explains what gets deployed, why and how, and what it prevents, things like SQL injection and cross-site scripting. And the next question says, can Rackspace help companies that want to migrate part of the, I see part is in with stars, part of the Windows environment to AWS? So Paul, you want to take that one?
Yeah, yeah, we can. We frequently may, a couple of different ways that might be handled. So maybe that a customer comes and says, well, we're not comfortable moving everything. We just want to take this one application, and we might treat that like a POC. We can also do hybrid architectures. So where we're supporting the AWS side and you're maintaining your on-premises. So there's a number of different options there. You're under no circumstances are you required to move everything.
Okay, so the next one here, did Powercord have any issues with moving from having full control of their MS SQL servers to relinquishing some of that control with RDS, a managed relational database service with MS SQL? Michael, you want to take that one?
Sure. There was mainly minor technical challenges, you know, because not everything is completely supported in RDS. So, you know, database mail, for instance, isn't supported. So we did have some jobs running, some SQL agent jobs that, you know, would send out through DB mail. So we had to swap those out to services. But other than that, it was well, and I think one of the DB engineers too mentioned one of the restores are slightly technically harder due to the unique management of the DB files. So restores are slightly different process than you might be used to, but you know, nothing exorbitant. It's not hard. It's just when you're getting in there, you're like, oh, okay, well, I got to do this a little differently. But we luckily weren't using a vast set of features from SQL that aren't supported. But I think the things that aren't supported are typically some of the edge case things in SQL Server that hopefully most people won't have a problem with just not using at all, or finding a different way to architect your app to handle those workloads you might be using that for.
Thank you, Michael. So the next one here I got for Paul. I like this question. What tools does Rackspace use to manage the migration?
So we have a number of different tools. Typically, it's going to vary on what happens. Our support personnel might use any number of tools to depending on the workloads that are involved. So I think to get more specific, I think I'd like to take that offline and talk to my support teams and identify what they want to share there.
Okay, and then let's see, how many weeks was the entire project finished to start?
So I can take that one, Paul. So on the Rackspace side, I believe was in the CloudFormation and all of that. So that portion of it was, as I recall, it was about 2 to 3 weeks. But we had a number of things to re-architect on our side. So, which I think is probably somewhat, you know, that's kind of hard to quantify against anyone else's application. Our application does, you know, certain unique things. So, but our migration process internally, we had a code turnaround time of about 2 months of re-architecting things. And most of that was around the area of making the application completely stateless. When you auto scale, you know, state for any type of scalability, any sort of state is going to be a problem for you for a scalability issue. So most of the work we did was around re-architecting our app. So again, that was about maybe 2 months worth of time to re-architect it. Again, it's a multi-tenant system, thousands of people using the same code base, so that wasn't a trivial thing for us. But start to finish, I guess if you combine all that time, I would say it was 2 months because basically Rackspace was working as we worked too. So it's not like we had to work serially. We worked in parallel. So about 2 months for us to cut it over.
Cool. The next question I got, in fact, I'm gonna go ahead and combine two questions here. One from Joe Guy and one from Joe Owens. It says, can you be more specific? This is Joe Owens and Bill Masek. How much size data was migrated? And also, can you discuss how you move data into RDS and S3? Sorry, this is a question from Joe and Bill, respectively.
Sure. So for RDS, as Paul mentioned, we just went with a straight full backup operation. So with our cutover, we were able to schedule some downtime. So that was the easiest way for us to go. If you have the availability to have a short amount of downtime, that let us, take down the existing app, put up maintenance pages, get those full backups and move those over. So the database size for that was only about 7 gigs compressed, not a ton, in terms of, kind of what volumes other people might be used to. But again, that data transfer rate between your pipes can obviously make that not take too long. For S3, what we did is we put jobs out on the existing servers to start syncing all of the things that were happening in production into S3 via the CLI. So we used PowerShell to run some automated scripts that would just continually sync that. So, I can imagine our users are uploading their imagery or any sort of static assets that it might upload to support the site. All of that was being continually synced. So it really wasn't difficult at all to keep all of those operations in check. And when we cut over, which by the way, we actually did yesterday. We actually went live yesterday.
Oh, nice.
The operation on our side only took us an hour. We were only down for an hour doing that. And that was mainly due to pulling down the database backups, taking everything offline, getting the backups, moving it over, restored, and then doing the DNS changes, which we had lowered our TTLs to about 300 seconds on the DNS so that, so that propagation of DNS changes was quick. So it went completely flawlessly, basically. And it wasn't too hard of a operation for us to complete. Of course, we did our due diligence to make that happen. But again, with Rackspace and everybody else and the tools AWS provides, it made that a lot easier for us.
That's really good to hear.
It's great to hear. And just missed on how much data was migrated? Do you have any?
Sorry, yeah, it was the compressed backups we pulled last were 7 gigs.
Okay, excellent. And we have time for only one more question. So I see here, this is from Duvernay. What do you use to manage the environment, monitoring, logging, and auditing?
So from the Rackspace side, we have a combination of things. We use, of course, AWS tooling, so CloudWatch for monitoring, CloudWatch logs. And then we have some tools that we have incorporated. We call Compass is one of those major tools that allows us to aggregate data from different locations and do things like auditing. It also helps with things like cost optimization. So the Compass tool really provides a lot of insight into the environments beyond monitoring and logging as well.